welcome back. We are now looking at travel graphs where we are trying to find out how to calculate the acceleration, deceleration, and distance. Looking at the example that we have on the board, the diagram below, so this is the diagram, shows the speed time graph of a 100-meter sprinter who accelerates uniformly for 3 seconds until he reaches a speed of 12 meters per second. He maintains the speed for 7 seconds and then uniformly retards for a further 4 seconds and comes to a stop. Calculate A, acceleration during the first 3 seconds, B, retardation at the end of his race, C, distance recovered in the first 10 seconds. So, this is the graphical representation of this statement here. You can see this line which slants upwards to the right, it talks about acceleration. Then this line here towards the end of the race here, which slants downwards to the right, talks about or is a graphical representation of retardation or deceleration. Then where you see this horizontal line here, this horizontal line talks about constant velocity. So, we are asked in this case to look at the acceleration. We know that formula which says acceleration is equal to final velocity minus initial velocity over time taken. So, using this formula to calculate the acceleration in the first 3 seconds, let's collect data first. Collect data. Our final velocity, in our case, our final velocity is 12 meters per second. Our initial velocity U is 0 meters per second. Then our time, in our case, is 3 seconds. So we need now to use this data to find the acceleration. In putting this data in our formula, we have our acceleration, our final is 12 minus our initial over our time as 3 seconds, which gives us our A as 12 over 3. So finally, our acceleration is 3 into 12, which gives us 4 meters per second square. So this is basically our acceleration for the first 3 seconds. So this is our acceleration for the first 3 seconds. Final, initial, t. So this is the formula that we use to get our acceleration. Let's quickly look at B. B, again, we are told to look at the deceleration of this sprinter. The deceleration, in other words, it is called the retardation of the sprinter in the equation. So again, looking at B, the formula that we use for deceleration is basically the same one that we use for acceleration. But this time around, it is a negative. It will give us a negative value. So again, let's collect the data. So we have data here. So deceleration, we are moving from here to here. It is actually from this velocity here to this velocity here, which is 0. So we have this velocity here because it is coming to a stop when we are, because the retardation is reducing speed. So it will reduce speed up to when it will come to a stop. Coming to a stop, it means the speed will be 0. So reducing speed from the current, from the initial speed. The initial speed is 12. Now it starts reducing speed to the part. So our data, our final velocity in our case will be the intended velocity, which is a stop, coming to a standstill, coming to a stop, which is 0. So 0 meters per second. So meaning that our initial, it is the former speed before reducing speed, which is 12 meters per second. Then time, we are looking at 14 minus 10, which is 4 seconds. Okay, so having collected that data, we need now to just input that data in the formula. So we have A is equal to final is 0 minus initial is 12 over T is 4. So that we have A is minus 12 over 4, which means A is negative 3 meters per second. So basically, this is our retardation or deceleration. You represent it as a negative acceleration, or otherwise you could say deceleration is equal to 3 meters per second. So whether you say acceleration is equal to negative, as soon as you say acceleration, you say negative. Whether you say deceleration is 3 meters, these two are the same. So basically, this is how you get the acceleration, the acceleration, so to say. So here we have 4 meters per second. Here we have negative 3 meters per second square. Okay. So this is the acceleration here. This is the deceleration here. The rate at which speed is being reduced here. The rate at which speed is being increased to here. Okay. Let's look at the final question on this scenario that we have. So we have C. C, we have to get the distance. We are told that we calculate the distance covered in the first 10 seconds. So the first 10 seconds, you can see in the diagram, we are from 0 to 10 here. This is the first 10 seconds. So, distance, we relate it to the area under a curve. So you can see from 0 to 10 seconds, the area that we are looking at is this one here. The area under a curve. So the area under this curve here up to 10 seconds. This area painted in red. This is basically representing our distance moved between 0 and 10 seconds. So actually we need to get the area of this shape. If we want, we can easily divide that shape into two smaller shapes where we have this triangle and where we have this rectangle. So our distance is, let's get the area of this triangular shape. Area of a triangle is 1 over 2. Base is 3 times height is 12. So this plus now the area of this rectangular shape is you have between here you have 10 minus 3, which gives you 7 by 12. So we have 7 by 12. So basically when we multiply this and this, then we sum, we shall get the distance from 0 to 10 seconds. So our distance here, will be 3 multiplied by 12 is 36. 36 times 1 over 2 is 18 meters. So from here, between 0 and 3 seconds, actually the distance that was traveled is 18 meters. Okay, now between 3 and 10 seconds, we have 7 and 10. We have 7 and 10. We are multiplying 7 by 12, so that we get 84 meters. So that finally, our distance that was covered in the first 10 seconds is 18 plus 84. 18 plus 84, which gives us 102 meters. So basically, this is the distance that was covered in the first 10 seconds. So here we have triangle, so you use the formula for getting the area of a triangle, which is half base times height. Now, between 3 and 10, you use area of a rectangle where you multiply the length and the breadth, you get 84 meters. So between 0 and 10, you sub here. So that's how come we have 102 meters. So basically, this is how simply we get the distance, the acceleration, and the retardation. Thank you for your attention.